Hello everyone, and welcome back to the Fluctus Channel. Modern salvage operations sit at the crossroads of engineering, seamanship, environmental protection, and emergency response. When a large maritime vessel is grounded, capsized, or sunk, the mission is never just about recovering steel. It is about protecting coastlines, reopening shipping lanes, preventing pollution, and sometimes rescuing people trapped inside. A complete salvage operation will involve divers, naval architects, crane crews, remotely operated vehicle teams, pollution specialists, and structural engineers all working together in unstable and often risky conditions.
Left surface.
At its most demanding, salvage is a controlled fight against weather, instability, corrosion, currents, and time. That is why salvage has such a long history in maritime operations. For centuries, sailors tried to refloat stranded ships or recover cargo from wrecks. But modern salvage has moved far beyond ropes and towing lines. Today, it relies on load calculations, underwater inspection systems, heavy lift vessels, precision cutting, pollution barriers, and carefully sequenced lifting plans. Every move has to match the condition of the wreck and the risks around it. In major cases, the site becomes a temporary offshore industrial zone, part shipyard and part emergency response center. Few modern cases show that more clearly than the Golden Ray disaster in Georgia. The 656-foot vehicle carrier capsized near Street, Simon Sound in September 2019 after departing the port of Brunswick. It rolled onto its side with thousands of vehicles still inside, creating one of the most difficult marine salvage operations ever attempted in U.S. waters. The first phase was not about engineering at all. It was about survival. Coast Guard rescue teams saved 20 people quickly, then worked to free 4 more crew members trapped inside the overturned hull. That alone showed how dangerous the situation had become. Rescuers were not entering a damaged ship in normal position. They were cutting into a massive vessel lying sideways in unstable conditions to reach survivors. Once the crew was safe, the real salvage problem began. The Golden Ray was too large, too unstable, and too environmentally risky to simply tow away or refloat intact. Engineers had to decide how to remove a ship resting on its side, partially submerged, structurally compromised, and still loaded with vehicles and hazardous materials. The solution was a sectional removal strategy. Instead of trying to move the wreck in one piece, the ship would be stabilized, cut into huge sections, and removed one stage at a time. Before major cutting began, the site itself had to be controlled. Crews had to monitor pollution, deploy containment systems, and deal with the effect of currents and seabed erosion around the hull. That meant protecting against scour, the erosion of sediment caused by water movement around the wreck. If the seabed shifted too much, the vessel could settle unpredictably, making removal even more dangerous. So, engineers were not just removing a wreck. They were constantly adjusting the surrounding environment to make the next phase possible. The cutting and lifting process became the heart of the operation. Each section had to be planned around structural integrity, weight distribution, and sea conditions. Every lift depended on the cuts before it. If one section shifted unexpectedly, it could affect the rest of the wreck. If a piece failed while under load, it could endanger workers, vessels, and the surrounding water. That is what separates major salvage from simple demolition. It is carefully controlled sequencing. Cut, stabilize, monitor, lift, remove, repeat. In many ways, that is the defining principle of modern salvage. Big maritime disasters are rarely solved by one dramatic move. They are solved by reducing the wreck into a series of smaller engineering problems and solving them one by one. The Golden Ray showed that clearly. A ship that might have been written off as impossible to recover became a carefully managed offshore dismantling project, one section at a time. A very different case reveals another side of salvage, not removing a giant modern ship from a shipping channel, but preventing an old wreck from becoming an environmental disaster. That wreck was the Coimbra, a British tanker sunk off the US East Coast during World War II. Decades after it went down, it still contained oil. That meant the wreck remained dangerous long after the war itself had ended. Recovering oil from a historic wreck is not the same as pumping out a damaged modern tanker. The hull may be corroded, broken, or unstable. Access can be limited. Internal spaces may be difficult to reach safely. In the Coimbra operation, teams had to combine diver work, remotely operated vehicles, testing procedures, and controlled pumping to remove the oil without causing new leaks. Divers were essential because some parts of the wreck still required direct human intervention. They could inspect conditions, prepare access points, and support recovery equipment underwater. But divers could not do everything alone. Some parts of the wreck were too hazardous or too uncertain. That is where ROVs became critical. These remotely operated vehicles let teams inspect the wreck, assess underwater conditions, and support planning without sending people into the most dangerous spaces. In modern salvage, that partnership matters. Divers bring adaptability and direct action. ROVs bring endurance, visibility, and reduced risk. Together, they make underwater recovery far more precise. The actual oil removal required patience. Crews had to identify what remained in the wreck, determine how to reach it, and extract it without destabilizing the site. That means testing, drilling, pumping, and constant monitoring. In a case like Coimbra, salvage is less about giant cranes and more about environmental control. It is slower, quieter work, but just as important. A wreck does not stop being dangerous simply because it is old. Large-scale salvage also depends on another class of solution: specialized heavy-lift vessels. Companies such as SMIT Salvage have built their reputations on using purpose-designed support ships, cranes, and refloating systems to recover vessels that would otherwise be abandoned or destroyed. These ships do far more than tow. They stabilize hulls, help transfer loads, support dewatering, manage lifting sequences, and provide the offshore platform for much of the work. In the most demanding operations, giant crane vessels effectively become floating shipyards. Entire wreck sections can be cut free and lifted directly from the sea. But even that often requires more than one lifting point, which is why tandem lifts are so important. In a tandem lift, two cranes or lift systems work together to share the load. That reduces stress on fragile or awkwardly shaped sections and allows crews to control rotation, balance, and movement much more safely. Without that kind of coordination, a lifted section can twist, crack, or fail under its own weight. That is the larger story behind salvage. Whether it is the Golden Ray being cut into massive pieces, the Coimbra yielding oil under diver and ROV supervision, or a heavy lift operation using tandem cranes offshore, the pattern is the same. Salvage is not brute force. It is sequencing, balance, and control. It is the discipline of taking something unstable, dangerous, and valuable, and moving it without making the situation worse. And when skilled engineers do it right, they are not just recovering a wreck. They are protecting waterways, preventing pollution, and proving that even the biggest maritime disasters can still be solved with precision. And if the Golden Ray and Coimbra showed how salvage teams deal with overturned wrecks and hidden environmental threats, the story of USS John S. McCain shows another side of maritime recovery, the challenge of moving a damaged warship across the ocean so it can be repaired instead of lost. The USS John S. McCain DDG-56 is an Arleigh Burke-class guided missile destroyer, commissioned in the 1990s and built as part of one of the U.S. Navy's most important modern surface combatant classes. In August 2017, the ship was involved in a deadly collision with a tanker Alnic MC near Singapore. The accident killed 10 sailors, severely damaged the port side aft section, and left the destroyer in need of major repairs. It was not simply a damaged ship. It was a frontline warship that had to be saved without exposing it to even greater structural stress. That is where the semi-submersible heavy lift vessel became essential. Instead of towing the destroyer across long distances in a weakened condition, the Navy used the heavy lift ship MV Treasure to transport it. The loading process itself was a major engineering operation. The damaged destroyer had to be positioned precisely, aligned with the transport vessel, and then settled safely onto the heavy lift deck. This is one of the great advantages of semi-submersible transport ships. By partially sinking their own deck, they allow large vessels to be floated into position, then lifted clear of the water for stable transport. In effect, the heavy lift vessel became a floating dry dock in motion. That is what makes this type of salvage and recovery so important. Not every damaged ship must be scrapped, and not every rescue is about cutting wrecks apart. Sometimes the mission is preservation. Sometimes it is giving a ship a second chance. When the destroyer arrived, the offloading process repeated the same level of care in reverse. By then, The operation had become a demonstration of what modern maritime engineering can do. And that is the larger story running through all of these operations. From the Golden Ray cut apart section by section, to the Coimbra emptied of oil beneath the sea, to the USS John S. McCain carried across the ocean on the deck of a semi-submersible giant, salvage is never just about wreckage. It is about control, precision, and bringing order in the midst of dreadful chaos. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.